Hey, so we are nearly there. Oh, 7 videos in. I wasn't far off thinking it was going to be almost 10, I think I said at the beginning. So, this one, similar to the last two questions, and I'll just zoom out and show you those that we did. It's all about optimization. Minimum, maximum, you're thinking turning points. This is called an optimization question. It's the same as what we just did, except there's no proof at the beginning. So, there's a little 3 marks for the proof, and actually, that can be a nice 3 marks if you get it, but it can be quite time intensive as we've shown. So, let's say leave them to the end. But the overall optimization process, we differentiate, we work out where our stationary point is, we double check the nature of it to know if it's a maximum or a minimum because we want to have either maximum or minimum depending on the question, and then we substitute that value of x back into original formula. So I'll take a bit more time doing this one because I feel like I was a wee bit rushed on the last two because it's quite a big question. So let's have a look at this one. Or can we pause? Okay, so find the value of p. There we go. Find the question first and manage together. So I will take this. I will say I've got p is equal to 2x plus 128 and 28x to the negative 1. That's a good start. P dashed is going to be equal to 2. Take away 128x to the negative 2. And p double dashed is going to be equal to 2 disappears plus 200 and what's that going to be 56x to the negative 3. So I want to write them nicely. That would be 2x plus 128 over x. Just in the question. This one be 2, take away 128 over x squared, and this one 256 divided by x cubed. So ready to go. This wants to know the minimum value of p, so it's saying we've got this function, and it's desperate to know what the kind of the the optimal part is. Okay, so we need to differentiate and then work out the turning. Okay, so let's differentiate first of all. So differentiate stationary points equal to 0. Sorry, I'm getting tired. I'm getting tired on this computer for ages. P dashed is equal to 0 for the stationary point. That's my kind of first thought. So let's take my differential, which is 2, take away 128x squared, that equals 0. 2 is equal to 128 over x squared. So I will do 128 over 2 is equal to x squared. Going to give me 64 equal to x squared. So x is going to be equal to 8, or it could be equal to negative 8. Then I'm going to say, all right, well, nature then. Let's find the nature. If I want to find the minimum value of p, I'm saying that p double dashed is going to be greater than 0 for minimum turning point, and p double dash would be less than 0 for a maximum turning point. Again, I always think your minimum turning point is an x squared. It's a positive number. I always think it's a bit like that. That's a positive number. It's a positive x squared, which is a minimum. So it'll be negative x squared. That one will be less than 0. So let's substitute those in. So I'll substitute an 8 and negative 8. So I'll do x is equal to 8, x equal to negative 8. So 256 over 8 cubed. 256 divided by negative 8 cubed. So this number should really write proper. I should say, p double dash for negative 8 equals, and oops, didn't want to do that. Don't do that in your exam. Yeah, just to keep it looking. P double dashed positive 8. Okay, so p double dashed positive 8 is going to definitely be greater than 0, and p double dashed negative 8, that's going to come out as a negative because the bottom will say negative. So I'm looking for a minimum turning point that's going to be when p is 8. P is equal to 8 for minimum turning point. I was just going to draw the little shape. So don't want this one. I want P is 8. And then final answer of this strategy. I'm just going to substitute P is 8 into my original formula. So I've got P to 2x plus 128 over x. I'm going to sub that in. So P is equal to 2 times 8, 16, plus 128 divided by 8. Just give me 16 as well. Just do a little check. Carry the 1 and 4, 6, 8 are 48. Yep. And that gives me 32. And just hit my units. Fantastic. So similar to the last questions, but without, pardon me, the complications at the beginning with the proof. So write your equation out, set it up. So move that x up, differentiate it, double differentiate it. You see, I've tried to do this, tried to keep it all in line to make life a bit easier. And you should start to notice a pattern. If you make a mistake, you would maybe not see 1, 2, 3, you might see 2, 2, and then, oh, that's wrong, that has to be wrong. You get negative to positive, this number is doubling. So just try and watch for the patterns. And then I've rewritten them again on the side, just in a nice way. And that's the equations that I've used down here because I can substitute into these. I can't substitute into these. So yeah, I hope you find that more useful than the nature table. Um, and for this one, again, see how it's very similar rearranging. We add this term to both sides, and then it's quite straightforward after that. Very similar on the other questions as well. If I just scroll over, see, we're adding that term onto both sides. Very similar. Adding that. Yeah, that was a slightly easier one. Yeah, but we're separating it to put them each other. So it's similar for all three questions, but that's a very standard end of the paper question, and that's us finished with optimization. I'm knackered after doing that. The questions are long, so yeah, practice.